All right, so we have the greatest worksheet we're going to do for good reference for your project. It says a large university has 5 sections of statistics that are scheduled to meet at various times with a variety of instructors. The table below shows the results of a random sample of students. Okay, so we're going to total them up to find out how many we have. If we had 22, 15, 29, 16, and 23, we get 105 students. Okay. So if we divided that evenly, okay, what we expected would be 105 divided by 5, which is 21 each. Okay. State an appropriate pair of hypotheses for testing whether students exhibit a preference for certain sections of statistics. All right. So I have my ho and my ha. So for ho, there is no preference. And my ha is, well, there is a preference. Calculate the expected counts above. I did that already. 105 divided by 5 equals 21 each. Okay, check the conditions for performing a significance test. Well, first we check for random, if I can spell correctly. Random. And that was given. It did say that in the initial, so I'm good. Number, well, we have greater than 30, so we're good to go. We have 105. All right, calculate the chi-square. Now, I'm not going to do this all the way through. I'm just going to put the first one. X squared equals 22 minus 21 squared over 21 plus dot, 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 dot. So you would do this for each of them. And what you're doing basically is you're taking, and I just want you to understand again where. We're going to use the technology, but I want you to understand where it's coming from. You're doing the observed minus the expected. And you do that for each one. So the next one would be 15 minus 21, 29 minus 21, 26 minus 21, and 13 minus 21. And you would do that all these times. Okay? But you can just use the staplet, which you already know how to use. Okay? And when you do that, you will get 9.0476. All right? Find the p-value for these data. Well, first off, we have 5 sections, so the degrees of freedom is going to be 5 minus 1, which equals 4. Okay? And we're going to make our lovely graph like right there. Okay? And our p-value is all the way out here. You know, very little shading. And when you use our technology to calculate it, we're going to get a p-value of 0.0599 approximately. I'm sorry, I think I said p-value before. Obviously, that meant a chi-squared. Apologize for that. Our chi-squared is there, which gives us a p-value of 0.0599. That is, and that's not negative, that's approximately. Okay? That is my area under the curve. In other words, this little eensy-weensy tiny area there, okay, is my area under the curve. Not even, about 6%. Make a conclusion in the context of the problem. So this is that same statement we've been doing every time. Since my p-value I always like to put in parentheses what it actually is greater than my alpha. Again, what is that? 0.05. We fail to reject the null. we conclude there is no preference. I don't know how that just happened, but that was cool. Preference on section time. All right, for the next one, since it is more applicable to the project, I'm going to actually go through the technology. So we're going to be using the multiple groups. Okay, so for that last example, we would have used single group, and we would put our stuff in here and let it do all the work and give us all information. But we're going to be using this one right here, which looks like this. So it says there are 3 judges in a county courthouse. A random sample of jurors for each judge was taken. The table below shows the number of male and female jurors chosen by each judge. So we have Judge ABC, and then we have men and women chosen on the jury. All right. So I'm going to go and just put that right into my technology here. Obviously, okay, never mind. This was a sample one. I'll just start a new one. All right. So it said men and women like this. I'm just copying it right off of the paper, the information given to us. And we have Group A, Group B. Little type for me. We need one more group. So we say Group C right here. Maybe get the old type. C. There we go. All right, then we just fill in our numbers. And we had 230 here. And 325 here. 325 men in Group B. And 300 men in Group C. This is not Sparta. And then Group A of women, we have 129. Group B, women, we have 150. And Group C, there is 200. All right. My old eyes deceived me. It was 120 here. All right, at this point, we just hit begin analysis. Let it do the work for us. Again, you can choose for your project, what kind of stuff you want to get from here. Whether you want to do a side-by-side. That wasn't supposed to happen. You move back up here. So you can choose a side-by-side. You can try to do a segmented. Some people like to do this mosaic one, whatever. You choose what you like. Okay. But that's good stuff to put into your project. Then you have your summary statistics, right? And right off the bat, we're going to hit perform chi-square, okay? And there's a lot of information down here. So we're going to come over here now, back to our worksheet, and start answering some questions. So it says the county commissioners are wondering if the judges are favoring one gender over the other. Well, right off the bat, you can see there's a higher number of men than women, but is there convincing evidence to suggest the juror gender is related to judge? Juror, gender, judge. That's nice and challenging. Perform a test at the 0.05 level. So state an appropriate pair of hypotheses. So we're going to go with ho and ha again. And pretty much this is the same every time. Our ho is going to be there is no association between gender and judge. And the ha will be, yes, there is. And I'm just going to do this to save time. So there is an association. So this is when you set it up for your project. Your ho is going to be there is no association. And the ha is there is an association. Simple. Every time. Doesn't matter what question you do. That is what you're doing. All right. It says calculate the expected counts. Well, if we go to our handy dandy numbers here, expected counts is right here. It gives us to us right here. So all we have to do on our paper here is to copy it down. So I'm going to put a box like so. And I'm going to put 225.85 and 306.51 and 322.64. Obviously, we cannot have a part of a person, but these are the mathematical expected numbers. 168.49, and 177.36. So that comes right off of here. So again, after you say perform chi-square test for homogeneity, you get your expected counts right here. You also get your chi-squared, and you get your p-value, okay? Which is really nice. All right. So I'm going to come back here to our paper, and it says check the conditions. Well, random, you betcha, given to us. So we hit check. All right. And all of our expected, I was not using my brain before. So when we're doing it here, it's not based on the number, it's based on the expected counts. So on this previous page, I messed up, I apologize. When I said greater than 30, my expected counts are right here, 21, and those are all greater than 5, okay? So if we go here, back to this one, again, I apologize. All of these numbers here, all the expected counts, are clearly greater than 5. So greater than 5, check. So I forgot I should go back and change this to 5, not 30. That was my bad. Sorry about that. Hopefully brain will start working later today. D, calculate the chi-squared. Again, I'm just going to write the first one just so you see where it comes from on this one. And on this one, the first one was 230 minus 225.85. All that being squared divided by 225.85. Plus, and then you'd go on and you would do it for all of them, okay? Not going to make you do it, but it is good to model that just so you understand where the numbers are coming from instead of just from the magic box we call our computer. So our chi-squared number is 7.839. Find the p-value. Well, again, that was given to us. If we look right here, so there's my chi-squared, here's my p-value, 0.02. So the p-value for this is 0.02. All right, if we're going to graph this, obviously 7.389 is going to be this little tiny amount here, and my p-value is 0.02. Technically, just so you know, it's 0.0199 rounded. And then my conclusion. Again, same statement. Since my p-value of 0.0199 or 0.02, whatever you put, is less than my alpha, which is 0.05, we will reject the hoe and conclude there is an association between gender and judge. And that is it.